The math behind AI. The secret language that powers the future. Intro. The hook. Imagine standing inside the control room of the world's most powerful superintelligence. Screens are glowing. Data is flowing like rivers of light. AI systems are diagnosing diseases, forecasting markets, translating languages, creating art, and even holding conversations with billions of people. But beneath all this lies a silent force. A force with no voice, no face, no ego. A force older than electricity, older than computers, older than science itself. Mathematics. Today, we're going to uncover the exact mathematical ideas that make AI possible, and why mastering them gives you superpowers in the 21st century. Welcome to The Math Behind AI. Let's begin. Part 1. Why math is the heartbeat of AI. Artificial intelligence is often described as magic. But the truth is, AI is pure mathematics wearing the costume of technology. Every prediction, every decision, every line of code, every neural network is nothing more than math transforming numbers into meaning. To build AI, you don't need millions of lines of code. You only need a few powerful mathematical concepts that repeat endlessly. Patterns, relationships, optimizations, probabilities. Once you understand these, you can understand any AI model in the world. Let's explore the 4 pillars of AI mathematics. Part 3. Pillar 2. Calculus, the engine of learning. Math doesn't just help AI think. It helps AI learn. At the heart of every machine learning model lies one simple idea. Make a prediction, compare it to reality, reduce the error. This process is driven by calculus, specifically gradient descent, the most important algorithm in modern AI. It answers the question, which direction should the model move to make fewer mistakes? Imagine standing in the mountains at night. Your challenge is to walk downhill in absolute darkness. You can only feel the slope beneath your feet. This is gradient descent. The slope is the derivative. The lowest point is the optimal solution. And calculus is the flashlight that guides the model toward intelligence. Without derivatives, deep learning would not exist. Training a neural network would be impossible. So if linear algebra is the structure of AI, calculus is the motivation behind its movement. Part 4. Pillar 3. Probability. How AI handles uncertainty. AI never says, I'm 100% certain. It says, I believe this is 78% likely, or 92% likely. This is probability theory at work, the mathematics of uncertainty. Probability powers, spam detection, a medical diagnosis, weather forecasting, fraud detection, a large language model's next word predictions. Every time AI chooses the next word in a sentence, it's running a sophisticated probability calculation. Out of all possible words, which one is most statistically likely to come next? This is why a model can complete your sentence, write a paragraph, or generate an entire book. It's probability, not guessing. Understanding Bayesian thinking, distributions, and likelihood unlocks the predictive power behind AI. Part 5. Pillar 4. Statistics. How AI understands the world. AI models don't just learn from data. They become the data. Statistics teaches AI how to summarize data, detect patterns, identify anomalies, infer relationships, make decisions. Every chart you've seen, every trend line, every prediction is built on statistical reasoning. Without statistics, AI would drown in data. With statistics, AI turns oceans of information into actionable insight. Part 6. Why learning AI math makes you unstoppable. You might be thinking, do I really need to be a math genius to succeed in AI? The answer is no. You don't need to solve advanced equations. You only need to understand the concepts behind them. Because once you understand the mathematics, a neural network stops being scary. AI models become intuitive. You can build, diagnose, and improve systems with confidence. You can move from prompt user to AI creator. Math is not a barrier. Math is a key. It unlocks the door to the entire future of technology. Part 7, How to Master AI Math Step by Step. Here is the path the top AI engineers follow. Step 1, Linear Algebra. Start with vectors and matrices. Learn how transformations work. Visualize everything. Step 2, Calculus. Study derivatives and gradients. Understand how optimization works. Step 3, Probability. Learn distributions, conditional probability, and Bayes' rule. This is the soul of prediction. Step 4, Statistics. Focus on averages, variance, hypothesis testing, and correlations. This is how AI understands the real world. Follow this roadmap even slowly, and you will gain a deep, unshakable understanding of AI. Conclusion. The future belongs to those who understand the math. AI is reshaping the world faster than any technology in human history. And the people who understand the mathematics behind it become innovators, creators, leaders, and architects of the future. You don't need to memorize thousands of formulas. You only need to understand a few timeless mathematical ideas, the same ideas that power every AI model today. Because in the end, AI isn't magic, it's mathematics made visible. And once you master the math, you can master the future.